All right, we are looking at simplifying rational expressions. This is the beginning of our chapter 7. So the first thing we want to look at is which expressions are equal to 1. Because when we are simplifying, we are going to divide out all of the pairs that equal 1. So we have 4 over 4. Clearly we know this equals 1. When we look at the next one, it's 2 plus 4 divided by 2 minus 4, which gives me 6 over negative 2, which definitely does not equal 1. When I have 3 plus 4 and 3 plus 4, or 3 plus 4 divided by 3 plus 4, that gives me 7 over 7. So yes, that equals 1. Because I have the same numbers and I'm adding same sign. And would it be the same if I had 3 minus 4 over 3 minus 4? Yes, we get negative 1 over negative 1, which equals 1. So again, even if it was minus, it would be okay. So then that leads us to the next example, when x is involved. And we have x plus 4 divided by x plus 4. And if you think of it in terms of the one we just did, it doesn't matter what we plug in for x, we're going to end up with the same thing in the numerator as we have in the denominator. So yes, this x plus 4 over x plus 4 equals 1. Now, is it the same if it is x plus 5 and x minus 5 on the top and the bottom? Well, if we go back to our second example, 2 plus 4 and 2 minus 4, that didn't give us the same result on top and bottom, which would equal 1. So when we have x plus 5 and x minus 5, it doesn't matter what number I plug in, I'm not going to equal a positive 1. Even if I put in 0, I get a negative 1. So this one is not equal to 1. And then lastly, x squared minus 9 and x squared minus 9. It's same on top as it is on the bottom. And so this is also equal to 1. So rational expressions are fractions with polynomials in the numerator and the denominator. So they're in the form of p of x over q of x, where p and q are polynomials. So let's look at some simplifying rational expressions. We have two main steps here. The first is to factor the numerator and the denominator, which is why we started with factoring last week. A little bit of review of factoring for us. So we're going to factor the numerator and factor the denominator, and then we'll divide out the common factors that equal 1. And we're working on using that terminology over canceling, because we're actually dividing the two common factors because they equal 1, and that's why it simplifies. So x squared minus x minus 12 is equal to, how does that factor? What two numbers multiply to negative 12 and add to negative 1? So that gives me x and x, multiply to negative 12, add to negative 1. I'm giving you a second to think. It's negative 4 and positive 3. And then x squared minus 9 is the difference of squares. That factors to x minus 3, x plus 3. Now, do we have common factors that divide to equal 1? We sure do. We have x minus 3 divided by x minus 3 equals 1. And so my simplified rational expression is x minus 4 over x minus 3. And we'll talk a little bit later about the domain. I'm going to add it into this in case you're absent for a discussion about it. But the domain is any values that we are not allowed to use. And the first and foremost rule in mathematics is that the denominator is not allowed to be 0 because we can't divide by 0. So to look at the domain, we want to look and see what values will make the denominator 0. So I can set x minus 3 equal to 0. And I can set x minus, or an x plus 3 equals 0. And really I'm looking at that they are not equal to. These are the values that x cannot be. So x cannot equal 3, and x cannot equal negative 3. And that would be our domain, x such that x cannot equal 3. Wow, what are they doing? And negative 3. Okay, so it would be all real numbers except those. And we want to do that before we simplify as well. So what I'd like you to do right now is pause the video and do the next problem, and then unpause it when you're done and see if you get the same answer as me. Pause it. Okay, you should have done it and unpaused by now. I'm going to factor the numerator. I want what two numbers multiply to -3 and add to -2. So I have x minus 3 and x plus 1. That multiplies to -3 and adds to -2. And then what two numbers multiply to -6 and add to -1? That's x minus 3 and x plus 2. And my common factor here is the x minus 3. But before I do that, let's look at our denominator. What values of x are we not allowed to have? The denominator cannot equal +3 and -2. Those would each make the denominator 0, and therefore it would be undefined. So all real numbers except 3 and -2. Now I can divide out my common factor, which in this case, where I have an x minus 3 divided by x minus 3, which equals 1. And what's left is x plus 1 over x plus 2. And that is my final answer. Okay, let's look at two more examples. We have x cubed minus 125 divided by 25 minus x squared. So again, step 1 is to factor. The numerator of this fraction is what kind of polynomial? I hope you recognize this as a difference of cubes, perfect cube, x cubed, and 125 is 5 cubed. So that's our a minus b, a squared plus ab plus b squared factoring pattern. Our a is x and our b is 5, because 5 cubed gives us the 125. So we have x minus 5, and I have x squared plus 5x plus 5 squared, which is 25. And then the bottom factor is 25 minus x squared. We can say that's 5 minus x and 5 plus x. That's how we could factor it that way. How else could we factor that? Sometimes we don't like to look at it that way. We could look at it as negative x squared plus 25. And if we factor out a negative, we get negative on the outside x squared minus 25. And then we have a negative on the outside, x minus 5, x plus 5. When we look at these two factors here, with the negative and this one, let's look and see what we have. Because if I take the negative and distribute it into that parentheses, I end up with negative x plus 5. That's distributing that negative. And the point of this is to show you how we're going to cancel out common factors. Because at first glance, it doesn't look like we have anything that's exactly the same. And as we do that, then we can say that that is equal to, we can rearrange it, 5 minus x. So negative x minus 5 is equal to 5 minus x. So what that means is if I have a problem like this, where I have x minus 5 over 5 minus x, I can think of these as opposites. And when they divide out, they leave that negative behind. Because I'd have to factor out the denominator, then I'd have that x minus 5. I would end up with x minus 5 over negative x minus 5, and that cancels and it leaves behind that negative 1. So when I divide this out, I can divide out the x minus 5 with the 5 minus x, but it leaves behind a negative 1 because they're opposites. And how does that look in our final answer? It ends up being x negative x squared plus 5x plus 25 over 5 plus x. And addition is commutative, so you can write that as x plus 5 if you'd like. But subtraction is not. And that's your final answer. Let's think about the domain a little bit here. If we go back to our original problem before we canceled anything out, before we divided anything out, we have positive 5 makes that factor negative, and negative 5 makes this factor negative. So my domain is x does not equal 5 and negative 5. So I want you to start thinking about that and writing that down on your homework. Okay, write down those domains. And let's see, let's do this last one. This one looks kind of funky. It's these problems that you guys get stuck on factoring all the time. So we're going to look at it. When I have lots of different variables in here and I only have 2 terms, I'm probably going to factor out the greatest common factor. And so, I think I forgot. Well, anyways, let's see. What can I take out of this? I can take out a, I really want to add a 6 in here. No, a 4. Let's make that a negative 4x squared y. Otherwise, it's not going to serve my purpose. So when I look at my 24 and my 4, I can divide out, I can factor out a 4. My lowest exponent is the x squared, so I can take out the x squared. That's my lowest exponent on the x. And I can take out a y. That's my lowest exponent on the y. What's left is 4 times what would give me 24? A 6. 4 times 6 is 24. If I'm taking 2 of the x's out, I have 1 more left, and I'm taking 1 of the y's out, so I get y cubed. And then in the next one, I've taken out the x squared and the y and the 4, so it becomes minus 1. Close the parentheses. I can't just leave it empty because when I distribute it back out, I have to get what I started with. So there has to be something here to multiply it by. If it's 0, it becomes 0, so I have to have that 1. And then my denominator stays the same. There's nothing to factor out because it's only a single term. 28x to the 5th y squared. Now I can kind of ignore what's inside the parentheses. I can't divide into that, but I can divide what's in front. And what's in front, I can say that 4 goes into 28 7 times. 4 over 28 reduces to 1/7. And 2 of these x's cancel 2 of those x's, which leaves me with 3. And 1 of these y's cancels 1 of those y's and leaves me with 1. So what I'm left with is everything in front cancels. 6xy cubed minus 1 divided by 7. I'm left with x cubed here because 2 of them canceled. And y to the first power because 1 of them canceled. So this is my final answer. Now what do we do for domain on this type of problem? Our original problem, the denominator is 28x to the 5th y squared. And basically there's no plus or minus in there, so x and y just are not allowed to equal 0. So we'd say our domain, x and y, such that x cannot equal 0 and y cannot equal 0. So it would cause us to divide by 0. And that is your lesson on simplifying rational expressions. It's the same notes that we're going to do in class.